Well, good afternoon. Welcome to Space Oddities, and thank you for joining us on this Sunday afternoon for the return of the OSIRIS-REx asteroid sample from Asteroid Bennu. Might well prove to be an historic day because nobody as yet knows exactly what that sample is going to reveal. However, more of that later. We're expecting the probe to land in about 40 minutes, Dan? Something like that, 45 minutes?
Yeah, but it's supposed to re-enter the atmosphere about 3:42 our time, or that's 10:42 Eastern Forward Time in the USA.
Okay, and they said it would be about 12 minutes to the ground
Yeah,
from the top of the atmosphere.
like that, yeah.
So, if all goes well, we will have a sample of an asteroid to distribute among the world's scientists for analysis over the next several years. I'm joined this afternoon by what to some of you may be familiar faces. There's Daz, there's Roger, and there's Michael. How are you all, guys? Looking forward to this, are we?
Yeah,
Oh, yes.
really exciting. Yeah, it's taken such a long time for this to happen.
I know.
This sample left Bennu, what was it, 2 years, 4 months ago?
Yeah, 2021.
So it just seems a bit actually surprising that it doesn't seem it was that long, but the whole thing's taken about just under 7 years.
Yeah.
So
That's
yeah,
right.
it's exciting times.
Like it was yesterday.
Yeah.
Well, yeah, because
Well,
I can remember. I can't remember whether we did a show or not, or we just talked about it.
No,
but watching the streams,
we did a show about it because I remember we played that video of the actual sample collection.
Yeah,
right.
Yeah.
So, yeah. Anyway, if you're new to Space Oddities, we are Space Oddities. We bring the universe to you, and regardless of your level of knowledge. We have live streams on every Tuesday at 8 o'clock UK time, 3 p.m. EST, in which we discuss and talk about all the latest space news, all the latest space exploration news, anything relating to the universe, as well as a lot of other stuff that we do. So anything to do with the universe, we are here for it. And as well as the regular Tuesdays, we do our own videos, so you can have a browse through our channel and look at the various playlists of videos that we create. It's all about the universe, about which we're passionate. So here we are on a Sunday afternoon. As Daz says, it's been a long space voyage. I think the spacecraft has done about 2 billion miles in total, something like that. It all culminates with the return of the sample today. So before we join NASA for the actual return of the capsule to the Utah desert, let's actually have a look at the mission itself and tell you a little bit about what's going on. And I can hear voices coming from somewhere.
Yeah, sounds like a radio on or something.
Yeah, that's right. Anyway, so this is the sample return mission. This is Asteroid Bennu. I hope you can all see that. And just a bit of background. Of course, we know that asteroids are rocky or metallic bodies that orbit the sun, predominantly in the main asteroid belt between Mars and Jupiter, but not exclusively. There are all sorts of different groups of asteroids with different orbits. They are thought to be remnants of the early solar system, so they are, if you like, material left over from the building of the solar system. And they can tell us a lot, therefore, about the history of our little system of planets and the sun. Bennu itself is about 500 meters in diameter, so it's about the size of the Empire State Building or the Eiffel Tower, somewhere in that range. It's thought to be a carbonaceous asteroid, which means that it's rich in carbon and organic compounds. While we mention the word organic, don't forget that a lot of people think that organic is something to do with life. It's not. The word organic simply means any chemistry involving carbon. So Bennu is thought to have a lot of carbon and organic compounds because, as we know, carbon can form many different compounds and be involved in lots and lots of different types of chemistry, without which, of course, we wouldn't be alive. So good old carbon. Carbon, incidentally, is the only material in the only element in the periodic table capable of creating something like life. There are no real alternatives. So people over the years have had this idea that you could make life out of something other than carbon. No, you can't, unfortunately, because only carbon can take this myriad form that we see. in order to form the sort of the building blocks you need to light. But there we are. That's an aside. And a few more facts about it. It is about 500 meters across. It's at the equator, if you want to call it the equator, because it's sort of diamond shaped or rhomboid shaped. Its polar diameter is obviously a little more. It's hurtling through space with an average speed of about 63,000 miles an hour. It rotates once in 4.3 hours. It goes around the sun in 1.2 years. Its orbit is inclined at 6 degrees to the ecliptic, and it comes close to Earth every 6 years. And therein lies a tale, because if you run the clock forward, now that we know the exact orbit of Bennu, Bennu has a chance, but only a chance, of hitting the Earth in September 2187. And this is why we need to know more about it, because the more we know about it, the more we can devise a strategy to deal with such a terrible eventuality. If it were to hit the Earth, it would explode with the energy of 22 Hiroshimas. And although that's not what we call an extinction level event, if it landed in the sea, it would generate huge tsunamis that could wipe out a coastline. So this is why it's very, very important to know more about asteroid Bennu. And here's an animation put together from images of Bennu taken by the OSIRIS-REx spacecraft of Bennu actually rotating. So this is what it looks like. It's got a very uneven surface. The initial measurements seem to indicate that it had a smooth surface, but as we can see here, it definitely does not have a smooth surface. This is what the surface of asteroid Bennu actually looks like. It's not really smooth at all. So let's go on a tour of asteroid Bennu, thanks to NASA.
In December 2018, after traveling for 2 years, 101 days, and over 1.2 billion miles, NASA's OSIRIS-REx spacecraft arrived at its target, near-Earth asteroid Bennu. OSIRIS-REx is the first mission to explore this primitive remnant from the origins of the solar system, designed to study the asteroid and return a sample to Earth. Bennu is a dark, diminutive world, roughly the height of a skyscraper, and now the smallest body to be orbited by a spacecraft. Prior to arrival, it was known to have low thermal inertia, a characteristic of fine-grained materials like sand. An infrared spectrometer on OSIRIS-REx confirmed this property, leading scientists to expect a predominantly smooth surface. But the first close-up views of Bennu delivered a major surprise. In exquisite detail, the mission's cameras revealed an unrelenting rockscape dominated by boulders. By combining these images from OSIRIS-REx with its laser altimetry data, we can take a tour of Bennu's remarkable terrain. The first stop is Simurgh-Saxon. This prominent boulder defines the asteroid's prime meridian and serves as the basis of its coordinate system. In Persian mythology, the Simurgh is a large and benevolent bird and the possessor of all knowledge. Saxon is Latin for stone. To the northeast lies the largest boulder on Bennu. Measuring over 300 feet in length, Rock Saxon is a colossus longer than a football field. It is also rich in a type of iron oxide called magnetite, which was used by mariners as an early form of magnetic compass. In Arab folklore, the rock is an enormous bird of prey that can clasp elephants in its talons, as well as stranded sailors, like the hero Sinbad. Continuing northeast over the equatorial ridge, we arrive at Gargoyle Saxon. This striking boulder is among the darkest on Bennu, though it clutches a much brighter rock that is about the size of a person. In medieval legend, gargoyles are dragon-like, winged monsters that can breathe fire and that guard cathedrals from evil spirits. Our next destination takes us far to the east. At the northern end of a small crater lies Ocypete-Saxon, a comparatively bright boulder measuring about 33 feet in diameter. Ocypete-Saxon is located near one of 3 sites where Bennu ejected small particles into space in early 2019, displaying its dynamic and evolving nature. In Greek mythology, Ocypete is one of the three harpies, the half-maiden, half-bird personifications of storm winds who would carry evildoers away from the earth. In the creation stories of ancient Egypt, the universe began as a formless, endless expanse of water. From this primordial sea arose the primordial mound, Benben. It was upon this rock that the god Atum settled in the form of the Bennu bird and sent forth the call that shaped creation. The story of Benben harkens to the mounds of fertile silt that once emerged from the receding floodwaters of the Nile, and it provides a fitting namesake for the tallest boulder on Bennu. Protruding by over 70 feet, Benben Saxon is so tall that it was first detected from Earth. Now, we can appreciate this monumental feature in detail using data from OSIRIS-REx. The final stop on our tour is a cluster of exceptionally bright boulders scattered across the southern hemisphere. They bear the spectral fingerprint of pyroxene, a mineral found in igneous rock that is unlikely to have formed on Bennu. These boulders most likely originated on the large asteroid Vesta and were delivered to Bennu's parent body through meteoroid impacts. Although it is small in size, Asteroid Bennu has proved to be a fascinating world, abundant in geographic features that have defied our expectations. Thanks to OSIRIS-REx, we can now explore Bennu to uncover its composition, its evolution, and its ancient memories from the origins of the solar system.
So there you are, that's Asteroid Bennu. And we're going to have a look now at what is in store this afternoon, the last phase of this momentous journey back from the asteroid that began 2 years ago.
OSIRIS-REx stowed its bounty and closed its sample return capsule. It bid farewell to Bennu in May 2021, embarking on a 1.2 billion mile cruise back to Earth. Now, 2 years and 4 months after leaving Bennu, OSIRIS-REx is closing in on the place where its journey began. On September 24th, the spacecraft will approach to nearly 63,000 miles from Earth. It will power up and release its sample return capsule at 4:42 a.m. Mountain Time. The capsule must be jettisoned within a narrow time frame and at just the right angle to hit its target, an area of roughly 250 square miles in Utah's West Desert. Once the capsule is away, OSIRIS-REx will fire its thrusters to avoid colliding with Earth. At 8:42 a.m., the capsule will streak into the atmosphere at a blistering 27,000 miles per hour. It will race across the western U.S. and begin to glow with heat, allowing infrared trackers on the ground to chart its progress. As it pushes deeper into the atmosphere, the capsule will rapidly decelerate, subjecting the Bennu samples to a punishing 32 Gs. About 2 minutes after entry, it will slow to Mach 1.4 and deploy its drogue parachute, stabilizing its descent. The capsule will enter special use airspace at 8:46 a.m., almost 10 miles above the Department of Defense Utah Test and Training Range. Radar stations will lock on and track it to within 30 feet of its landing site. At 8:50 a.m., the capsule will extract and deploy its main parachute 1 mile above the ground. It will make its final descent at a leisurely 11 miles per hour, like a marathon runner savoring a victory lap, before touching down in the desert soil at 8:55. After ground teams retrieve the capsule, the Bennu samples will be taken to NASA's Johnson Space Center in Houston, Texas. The sample canister will be opened in the Astromaterials Acquisition and Curation Facility, and the samples will be curated, distributed, and studied for decades to come.
Well, there we are. So that's what we've got in store this afternoon. Of course, a lot of asteroids, in common with Bennu, are thought to be just these enormous piles of rubble held together loosely by gravity. And that looks to be very much the case with Bennu, as you saw from the sort of the surface of the asteroid. Let's have a closer look at the actual spacecraft itself, the OSIRIS-REx spacecraft. It's a NASA mission. It launched on September the 8th, 2016. So it's just over 7 years it's been away from the Earth. Arrived in December of that year. It spent 2 years orbiting Bennu and studying its surface. And on October the 20th, 2020, panel, do you know what else happened on that day of monumental importance? No? Oh, it was my birthday. And it landed on my birthday, 2020. OSIRIS-REx landed on Bennu and collected a sample. And the operation was called touch and go, because the spacecraft was just going to descend with a probe in front of it, just low enough to let the probe make contact, at which point they would fire a blast of nitrogen gas down the probe to disturb the material on the ground. And in the low gravity, that would fall back onto the collection end of the probe, and they would have a sample. That was the idea anyway, but we'll come to that in a moment. It didn't quite go as planned. The science objectives of the whole mission were obviously to study the surface and its composition, because if you're going to divert this from hitting the Earth, one way might be, we are talking about 2187 when it could happen, perhaps a nuclear bomb or something like that. Well, if you throw that at a rubble pile like Bennu, if you don't absolutely vaporize everything, you're going to cause problems, and the asteroid could just fragment and rain down, countless fragments upon the Earth's surface. So we need a sample. That's why we need to have a look and see what this asteroid is actually made of. And of course, that would allow us to study asteroids in general, and also to learn about the possibility of places like Bennu with its organic compounds. Could they be refuges for life? So quite a wide variety of scientific objectives. The spacecraft itself is equipped with 3 cameras, a low resolution for documenting the sample site, a medium resolution for navigation and mapping, and a high resolution also for navigation and mapping. Then we've got 2 navigation cameras. We've got the camera that will look at the operation of getting the actual sample into the return capsule. We've got an X-ray imaging spectrometer for mapping the elements on Bennu. We've got a laser altimeter to measure its shape and its size, and a LiDAR laser beam for measuring the distance to Bennu, because they had to actually position the spacecraft above the surface very accurately to get that sample, for which they used LiDAR. And also we have a visual and infrared spectrometer for mapping composition to help them choose where they were going to grab the sample from. And this is the actual moment it happened, and something really quite unexpected happened. So let's see actually what happened. So here goes the probe towards the surface of Bennu, getting closer and closer. Fire the nitrogen gas and look at all that material that came up. Far more material than actually anybody had predicted was just dislodged from the surface and collected. And what this meant, unfortunately, was that, and here's an animation of it happening, when the probe fired the nitrogen gas and all of this material was collected, the probe actually collected too much material. They were hoping for about 500 grams, and they actually ended up getting more. And this meant that the lid on the probe containing the precious sample was actually in problems, because they couldn't close it. And this is an animation of a few frames afterwards. You can see material actually coming out of the collection arm of the probe, the collection end. And this was a problem. They couldn't close the lid of this assembly here containing the sample to stop that sample flying away into space. And they tried all sorts of things. But in the end, the spacecraft returned to the Earth with this partially open, which meant in turn that a trajectory had to be devised which wouldn't shake more material loose from the collection tray, if you like. They were so scared of losing all of the sample. Luckily that doesn't seem to have happened, but some was lost to space. So in a way, this mission was, in terms of the sampling, too successful. So it just showed even more that Bennu is a loose, very loose collection of little stones and rocks. And it'll be interesting to see what the science shows about that. Here's how it was done. There's the return capsule, which is in 2 halves here, as you can see. the capsule that's returning to Earth on a parachute today into the Utah desert, and this is just a picture showing how the collection tray was actually put inside the capsule. The sample is going to be studied by the world's scientists, and as I said earlier, we stand to learn a lot about the history of planets, suitable environments for life, and of course it will help devise a strategy to do something with Bennu should it really threaten the Earth in the next century, because it does have a non-zero chance of hitting the Earth. So there we are. So that's that's Asteroid Bennu. Let's just get rid of that. So there we are, guys. What do you think?
Well, the sample, as you said, was put into the container ASAP when they decided, because they were going to do a spin test, which was going to tell them how much they'd actually picked up. But of course, they thought if they spin it, they're going to lose what they've already got in there. So they decided they'll put it straight into the capsule, close it all up. While it's actually in the capsule, it has been monitored. So any escaping gas has been collected and analyzed, and other things like that, because the instruments have to work at a certain temperature. They can't work at the temperature that space is. They have heaters on there, so it's been exposed to sort of like room temperature. So it has been monitored while it's all inside. So yeah, when it comes back, it's all sealed and everything. So hopefully they've maintained most of that material they picked up. And of course, as you said, what was it called? A touch and go?
Yeah,
That's right.
With their
tag
acronym.
tag.
Yeah, that's it. With their acronyms, because they love their acronyms, they call it a tag.
They have to.
Oh, yeah.
Yeah. So they've all So just in answer to that, somebody popped in the chat, what does the acronym mean? And it stands for OSIRIS-REx mission, stands for Origin Spectral Interpretation Resource Identification Security. And the Rex part is Regolith Explorer.
And there'll be a test on that later.
Yeah. So we'll also be checking the spelling.
Yeah.
So, but yeah, it's. I think it's one of the things they came up with the acronym before they actually thought of what they're gonna, what that's actually going to mean. It was, well, I think we had a discussion at the time. There were some really weird acronyms going around.
And isn't Osiris a Greek god anyway as well?
Yes. He's an Egyptian god.
Egyptian god. Okay.
Yeah, he's an Egyptian god. So. Yeah, they come up with these acronyms. Yeah, yeah, literally, other side of the Met. So it's really exciting. I mean, we're talking about that this is going to be coming into landing soon, but of course, this has been going on now for the last couple of weeks. The maneuvers have been made and things like that. So, do you just want me to run through what's actually happened, Andy?
Yeah, please, Michael. I think you said earlier today that the capsule has been released correctly.
Yes, it did.
Yeah.
There was a note on the NASA website about that, saying it released correctly, and they've also said that the spacecraft has now started its new mission. To go to its next destination.
And where is it going next?
Good question.
It's going to the asteroid Apophis, which is going to be making a close approach in a couple of years' time.
Yes. Yeah.
So they're sending it on. So it's not dead. It's gonna do stuff. I mean, if you pop my thing up, I'll explain that a little bit more, Andy.
I'll just let us join the NASA stream while you're doing that. Just see
what's going on. Dinosaur. Who's got a dinosaur?
And hey, look,
is that their 0G monitor?
No, it's far too big. So we're 30 minutes away from landing. 31, just under 31 minutes.
Mm-hmm.
Apparently, the Natural History Museum in the UK are going to get some samples too.
Whoa.
That's right. I read that as well.
And I was wondering how it will compare with the samples that we've already got from the moon.
That'd be interesting, won't it? That'd be really interesting. Do you think, as they did with the Hinchcombe meteorite, do you think they'll Do you think the Natural History Museum would travel to the Utah desert and dig up a bit of the ground where it landed?
Don't think so.
I think that's all. I think that's already been. That's part of the mission. That for the retrieval, they are actually going to recover the soil that it's actually
Really?
Yeah, landed in. Yeah, there's a lot of stuff that's going to happen to this when it to this.
Presumably that's in case the spacecraft has leaked any material.
Exactly.
Right,
and it's that's all going to be removed. And there's a lot going to happen to this capsule once it gets back.
Yeah.
So
let's hope the parachute opens okay then.
Yeah, we don't want a Genesis incident.
No.
No.
Which we can talk about a little bit later.
Yeah. Okay, so NASA aren't doing that much at the moment. They're just running the copying us basically. They're just doing the same.
Yeah, they're probably actually following our feed.
Yeah, they probably are.
Yeah.
How would that work if they followed our feed and we followed theirs? That would just sort of...
We'd have an eternal loop, and it'll be the end of the end of the universe.
Yeah. So, Roger, you're being very quiet there. So, what do you think about this going on today?
Well, it's all very fascinating. I mean, the media around the world seem to be going rather excited about this return after the short time ago, relatively speaking, of the landing. So I think they're all keeping their fingers crossed that it survives the 32 Gs coming into the atmosphere.
Yeah, definitely.
Yeah.
And
I mean, I think
the lid doesn't pop off.
Yeah, that's right. Well, this is the thing, because that lid is already open partially.
I always say, yeah, of course.
I hope nothing happens, but it is inside the capsule. So
yeah, this is what one of the things that they've got to look at when they open it all up is they know that they're now going to have the internal of the actual capsule itself. Because one of the first things they're going to do is fill the capsule with nitrogen to stabilize anything that's in there. Of course, it won't interact with any of the gases that are in there, so that when they get it back, they can siphon off any gas and analyze it and see what gases have come off and things like that. So there's, like I said, a hell of a lot that's going to happen when it comes back, and it's all going to be done in a nitrogen atmosphere. So
Ian actually asks, Daz, is it going to be contaminated by Earth stuff?
This is why they want to get nitrogen into it as soon as possible, because nitrogen, being an inert gas, reacts very little with anything, and it will keep any capsules pristine. So as long as the capsule doesn't split open, then we should get some pristine. Of course, they're still not really sure of how much material they've got. Because as you said, it filled up so quickly, because it actually penetrated 19 inches into Bennu's the body of Bennu, so the actual head completely disappeared.
Yeah. Well, we saw that very briefly, didn't we?
Exactly. And so it nearly disappeared 2 foot into the Bennu. It's so soft. Because they practiced doing the tags in different areas several times. So they knew what was going on. They even had enough gas that if they didn't pick up enough material at the first time, nitrogen gas, as you said, they puffed it out so to blow the material into the collector, that they could do a second go if they needed to. But the first go just literally filled the thing. And of course, like I said, they were going to weigh it by spinning the aircraft and by measuring the variation in the G-force. They could tell how much they actually had. But we're not going to know that for probably a few weeks now until they've gathered it all up, because there will be some loose actually inside the capsule.
Yeah, probably.
Of course, Professor Dr. Brian May from Queen was on his 3D viewing of Bennu to get the best location for the lander to get the samples at.
Yeah, that's right. Because because I did see that I think even Wikipedia may have an image which is 3D. So if you've got some 3D glasses, go and have a look at it. It'll give you a different perspective. is regards. Just going back to what's actually happened. The let me just. I think it was right. Let me go. 10 days ago, they did a course correction.
Let's have a look at your visuals, Daz, for this.
Yeah, okay then. So if I just quickly flick this on, one page, right. So in this Instagram, you can actually see on July the 26th, they did a big course correction. Because I suppose if anything had gone wrong with the thrusters, they didn't want it coming anywhere near Earth. So they had to correct it on July the 26th. September the 10th, they did another correction. Again, to make sure that it's actually going to hit Earth, which is nice. And what it did is they fired the attitude control system thrusters so to point it towards Earth, but it also reduced the speed, and this makes me giggle, 0.5 mile an hour to stop it flying straight past. So they slowed it down 0.5 mile an hour. And then, as you can see, the next thing is September the 16th, they did a final course correction. Again, that changed the velocity by 7 inches per minute to slow it down. And also it moved the predicted landing location 8 miles. Did it say which direction? It moved to east by 8 miles, so it would land in the center of this area, the landing area, which is in Utah, and it's the Defense Department's Utah Test and Training Range. It's the biggest open area that they could find. And then, of course, 4 hours ago, as Michael said, they had the capsule release. So send it on its way, and then 20 minutes later, OSIRIS-REx did its course alteration, so it will fly by the Earth on its way to its next mission, which is Apophis. Now, just one thing there: if this, for some unknown reason, this couldn't happen today, that course correction would have been different, and they would have sent it into a heliocentric orbit around the sun to bring it back. Because the next time that we could possibly get these samples back would be in 2 years.
Right.
But because this is happening today, and as you said, the capsule's released, it's on its way to Apophis now.
Oh, wow.
Yeah.
Now, what's the next few things? There's a few things that's going to happen. As Andy said, in a little while, in under 10 minutes, it's actually going to enter the Earth's atmosphere to begin with. And that will, of course, then start to slow it down. It's going to enter the atmosphere about 63,000 miles above the Earth, and it will, of course, that will start down. It will experience all the heating and everything else that will go on, and that then it will enter the thicker parts of the atmosphere, where it will then release its drogue chute. And the capsule will be traveling faster than 27,000 miles per hour, which is 43,450 kilometers per hour,
or 5 times the speed of a rifle bullet.
There you go. Look, see how many elephants. And
depends on the rifle, of course.
Yeah, of course. So that will dissipate some of the speed as it comes down,
right.
And then it will then actually release its main parachute about 10 miles above the Earth, which is 16 kilometers, and that will then, of course, really slow it down. And then, of course, that's the drogue chute. Sorry, I got that wrong. Then you got the main chute, which will be deployed, and that'll be 1.6 kilometers above the ground. And they're hoping to land it, and they reckon they could land it quite precisely. But the area that it's actually landing is a 36 mile by 8.5 mile landing zone, which is 58 kilometer by 14 kilometer. And of course, that's the Utah tester range.
Great. Can I just interrupt you for 1 second?
Yeah, carry on, mate.
Can we just go over to the NASA stream at the moment? I just want to test the sound level, make sure everybody can hear.
Yep, no problem.
Okay, thank you. Just give me 1 second, and let's.
Main asteroid belt. It's a NEO, a near-Earth asteroid with an
now.
orbit
How does that sound?
brings it in close proximity.
A bit quiet to me.
On Earth. Bennu is about 500
Okay,
meters in
let's try
diameter,
this.
which is taller than the Empire State Building. It
What about
rotates
that?
upside down on its
Bit
axis
better, yeah.
compared to Earth, with a
Okay.
tilt of over
How about that?
177 degrees.
Yeah, that's
Scientists
fine.
chose to
Yep,
study
that's
Bennu
okay.
because of its
Discovery
origin,
Okay.
operations. Helicopter
compounds,
2
and
has
mineral
departed
codes.
WIG. The station keep outside the landing ellipse.
All right, so you just heard that they have departed WIG. Excellent
Whoa.
progress.
Oh,
Fantastic.
good.
All right. Moving on, it isn't as smooth a surface as we initially thought. It's actually covered in pebbles and marked by these large rocks and boulders nearly everywhere. One boulder in particular that OSIRIS-REx had to navigate around was nicknamed Mount Doom and was the size of a 2-story building.
Ooh,
Bennu
You're all
holds the
doomed.
Guinness World Record of the
They
smallest object
just
to
to
be
mention the
orbited by a
helicopters,
spacecraft.
they're using 4 helicopters for this,
Now let's get an
Yeah.
update from Sophia,
and they will
who
be
is standing
going
on
in
the
at
edge of the
different
ellipse.
times.
Take it away, Sophia.
right.
Because one of the problems is because this is a testing ground, the first heli crew are going to actually make sure that there's no unexploded ordnance in the area before
Sure.
the crew go in. So yeah.
Oh, right. Okay. Now, just 1 second. There's something I need to do here because unfortunately, my face is being totally obscured by our logo.
You say that as if it's a bad thing.
There we are. That's better. Cheeky. Babs Windsor. Yes. Okay. So, the roving reporter from NASA is at the site, obviously.
Yeah.
We're coming up to just a few minutes actually before it should hit the atmosphere. So, Daz, could I ask you once the capsule's down, do you want to talk to us about similar missions that have happened in the past? And,
Okay, then I can do. Yeah, there's no problem at all there.
yeah.
If you put my thing back up, then I will quickly run through them. This is just a basic thing I put together, just a basic past missions that we've actually had sample returns from. Now, they're not all asteroid sample returns. I haven't talked about the moon returns or anything like that. I'm talking about things further out into space. So basically, if I just move this on, sample returns mission. Right, the first, and what I've done is I've done these by launch date, because you will find that some of them, things that launched later, also returned earlier than what the other one did. So we had Stardust, which visited the comet Wild 2, 81P Wild 2. And this basically flew through the tail of as well as you can see, the images that it took. And it flew through the tail of the comet, collected samples, which it then returned to Earth successfully on this one. The next one that came along, sorry, I'll just pop back to Stardust because Stardust, once it had finished and dropped off its samples, again, they reused the mission and the designation became Stardust Next. And that way, that it actually flew to Comet Temple 1, where we'll talk about later on about missions for redirection missions. When that is in, it was Temple 1 that Deep Impact collided with in 2005, and Stardust Next arrived there. I think it was a few months later, and it tried to take some images, and it I think here it is. So this is on the left. You've got Temple 1, and it took images of where Deep Impact landed. And as you can see, this is a more solid object. But the reason it's fuzzy is because all the dust in that hadn't settled back onto the comet. So that's the area, and you can see it on the right-hand side where the impact was. So that was redirected to another mission, just like OSIRIS-REx is. Then, of course, we've got Japan's... this is Genesis. Now, this was actually a solar particle and gas emission, and it was sent out to Lagrange Point 1, where it sat for a year, collecting particles that were being emanated from the sun, also any gas that was in the solar wind. And as you can see, these round dishes, you can see all these hexagons on there. Well, they're all different elements, because, of course, different elements will collect and attach itself to different gases and things like that. And as you can see, there is a tray there in the middle, and there's about 4 or 5 of them. They're stacked on each other, so they could actually swap them in and out as time went on, so that they didn't get overloaded. And of course, then this was returned to Earth to be analysed. The only problem was this is how it's supposed to be captured. It was an in-air capture of the parachute. This is how it was supposed to have gone, but this is what it ended up. The parachutes failed to open, and during the investigation, it was found that the manufacturers decided to not do one simple check when it was flown out, which have indicated that the parachutes would not have opened. But luckily, not all of the discs were damaged, so they did actually get some data from this, which was really good.
Yeah, it ended up being quite a success scientifically. But looking at that mess in the desert at the time.
Exactly, yeah. We don't want to see this today. We don't want to see this
No, we
today.
don't want to see this today.
There is an image of one of the scientists going through the samples, but he's wearing all the sort of like a hairnet and but he's got it sort of like in front of him on a tissue, and he's going through it, frying granules. So if there was going to be any contamination, he was done for.
Sure.
So that was Genesis. So we don't want to see this happening today. Then we've got the Japanese JAXA Hayabusa missions, which means Hayabusa means Peregrine Falcon. The first one Hayabusa went to asteroid Itokawa, where it grabs them. But with this, all they did is they sort of like had a double-sided sticky tab on the end of a probe, which they just gently touched down and then brought the actual thing back. Then we had Hayabusa 2. But also the Hayabusa ones also had little landers on them. But unfortunately, the Hayabusa 1 mission, the lander failed very shortly. Yeah. Hayabusa 2 went to Ryugu. And again, something I would just like to point out, if you look at these asteroids, if you look at them, they're almost the same shape. They've got this sort of like squarish shape, although they are round as well, around the waist.
But that could be Bennu we're looking at.
Yeah, it could be, and it's exactly the same. You can see it's all rubble. Again, as I said, it had landers, and this is what the image was from the surface of Ryugu, taken from one of the little landers. It was a little hopper, apparently.
Daz, we've got the first sight of the.
There we go.
Returning. I'm just going to put the volume on.
Wow.
So that must be in the infrared. Here it comes.
The punishing deceleration that spacecraft, that SRC, is experiencing right now, as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky. And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC. A phenomenal view of that streaking SRC coming in across the sky. At this point, we have entered in over San Francisco, California, and are very quickly going to be approaching the Utah test and training range just a little bit further to the east. Entry was at...
EO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 G-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC.
Yeah, they have, because of the great
Once again,
heat
as I mentioned, that sample is safe and
involved
sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere.
The collection crews have been issued with oven gloves or something like that still.
High altitude sample searching for that SRC. You can see it faintly on your screen there. Our next milestone will be expecting that drogue parachute deployment.
This camera work is good, isn't it? They're managing
300 feet altitude.
Keep it in the frame.
And as I mentioned before, that will stabilize our descent and slow us from hypersonic to subsonic speeds as we continue to target the Utah test and training range.
Expected milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute. Waiting to see that visual confirmation, but that is at 102,300 feet.
I'm just amazed at the targeting for the whole thing.
At this time, at 8:44 a.m. Mountain Time, the OSIRIS-REx spacecraft is at its closest approach to Earth. That will be on to its extended mission visiting the asteroid Apophis in the year 2029, continuing this incredible mission at another world.
Don't see a drogue yet.
And in just a few moments, we should enter into special use airspace at approximately 8:46 a.m. That's going to be at 10 miles off the deck here at Utah Test and Training Range.
I think their tracking system's gone down because nothing's moved.
You can still see that SRC on your screen very faintly in the distance. Still quite warm, that fireball that literally was a ball of plasma just a few moments ago when it first entered into the Earth's atmosphere.
Where's he looking?
That SRC is nearly 3 feet wide, 1.6 feet tall. It's a small object, so quite a challenge to track this as it comes searing into Earth's atmosphere.
Index where it is in relation to the camera view.
And in just a few moments, we should be entering into special use airspace. This area was specifically chosen for this mission. It's a wide open, vast desert space, relatively flat, perfect to land this sample today.
I think they should have stuck with the infrared.
We did, as I mentioned, have a couple days of rain here leading up to this event, so the ground is a little bit soft.
Still don't see a drogue.
Oh dear.
Oh. Is it coming in with
SRC?
Genesis 2.
Oh
this
no.
It's personal.
Sugar.
Streaking in.
Yes.
This is from our high altitude cam.
We may be wrong though. It's difficult to get the scale, isn't it? To see.
Unless that's the actual drogue chute we're looking at.
Could be.
Oh yeah.
Could be the parachute.
I'm praying it is.
Our next milestone, we should be expecting main parachute deployment at around 8:49 a.m. Mountain Time. That will be at around 5,000 feet elevation.
Because as you said, the capsule's only 3 feet across, so that could well be the
Continue to
drogue.
track
That's
with our
2 minutes
altitude
to
camera here.
main shoot.
As I mentioned, that sample is thermally isolated within that SRC, a very complex labyrinth network of piping and tubing leading into that sample canister within that just a few years ago was on the other side of the solar system from us sampling at Asteroid Bennu.
Amazing, isn't it?
Yeah.
The team has incredible precision on this mission as well. Just a few days ago, on the 17th of September, they did their final trajectory correction maneuver, TCM-12. This corrected our velocity by 3 millimeters per second.
Oh.
What's happened there?
That's crashed. Oh no, there's a
Oh no,
parachute.
there we are.
Hey.
Wow, and after an exhilarating
God, my heart
streak across Earth's atmosphere,
main parachute.
we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. There is that orange,
they heard us then.
colored parachute. Just a delight, a sweet delight to see in our sky here over the Utah Test and Training Range.
They've learned that to their cost.
Just hold that camera still.
Wonderful to see that deployment. That is at around 5,000 feet elevation above the Utah Test and Training Range. And now this is like a marathon runner savoring that last lap here as we approach the finish, that landing in the Utah Test and Training Range.
That confused me because we were looking at the sky and then suddenly we were looking at the ground.
Yeah, exactly.
Yeah.
Wonderful to see that.
And I think the chute deployed and then they carried on moving the camera, so it looked like it just fell out into the desert.
Of different tracking assets, and you saw Sophia out at the edge of that ellipse watching from Wig Mountain. The team there could potentially have a wonderful view momentarily as well.
Did he mention
We'll continue
Sophia?
to descend. Our next
Yes.
altitude descent will be at about 4,000 feet. Just a few
I thought
minutes away
Sophia
from
had
getting
flown
that
for
sample
the last time.
Yeah.
from the other side of the solar system.
It's been mothballed,
On
hasn't
the
it?
surface of Asteroid Bennu at sample site Nightingale.
Brought it out of
To
retirement
the
for
rugged
this mission,
terrain of the
obviously.
Utah Test and Training
Yeah.
Range.
Unless that's what they're going to use it for now, is tracking things coming back in.
Looks like winds are relatively low. Not a lot of rocking back
Michael,
and forth.
there's
as
your homework.
parachutes
Find out
seem to
what's
be
going on.
perfectly smooth coming down with the parachute there.
Yes, sir.
Continuing to descend.
If you don't, you'll be seeing
Slight
the
little bit of tilt
afterblast.
back and forth of our SRC
With
as
good
it comes
thrashing.
to its resting velocity of 11 miles per hour as it makes that final descent.
What a beautiful sight.
That parachute
Certainly
deployment
is.
was given internally by the spacecraft. All of what you're seeing now is autonomous on
Well,
board
it's
that
not going to
SRC.
do a Genesis. At least we can say that.
Yeah, that's good.
And once that successfully lands, the teams will begin the next crucial phase of this mission, the sample recovery operations. They've been rehearsing for this moment for months, literally
course, it's
years,
all CGI,
really,
you know.
leading up to this key moment.
Of
and
course,
are ready
in
to
the
begin
Earth's
those
flat.
operations to get that SRC into our portable clean room here and extract that sample canister.
I don't think they wanted to do a SpaceX and try and land it on a drone ship.
No.
According to my watch, we're about 5 minutes away from landing with our
5 minutes
SRC.
from landing.
Looks a lot closer than that, doesn't it?
It
And
does.
as we heard a
Yes,
few moments
it's
ago,
foreshortening
helicopters
with
1 and 2 are
the
already staged and ready to begin
telescopic
those recovery
lenses, isn't it?
operations
Yeah, exactly.
just as soon as we have confirmation of touchdown.
Oh, you can't see the actual capsule, can't you?
This
Yeah,
is
just
very
hanging
hard, so
below it, yeah.
This could be
It's
a little bit
swaying
faster, a little bit
away.
slower as we get
Yeah.
closer in. This wind speed here is a variable that is quite hard to predict, especially once you're high up in the atmosphere. We did
Sway
release
away.
a weather balloon earlier on this afternoon, or earlier on this morning rather, to get a profile of our atmospheric conditions. The team puts those into various models as they prepare for this key moment. But once again, they are a little bit hard to predict, a little bit of variability, so we may kind of bounce around a little bit on that predicted OSIRIS-REx sample return
Yeah,
capsule
because
touchdown
you
time.
said about the weather balloon released earlier in the morning. They did a go, no-go poll. It would have been about 7 o'clock
The ground
Eastern
really
Standard
closing in
Time.
now on that SRC.
PDL milestone. Helo 1 has visual on the
Whoa.
SRC below the chute.
Yeah, we've got
That
visual as
is
well, mate.
phenomenal. Let's see that view here from that first helicopter. They've got visual on the sample return capsule under parachute.
Oh,
that
yeah.
orange creamsicle colored parachute, really bright in the morning light over the Utah Test and Training Range.
Now put us back to
Great
the other
view
one.
of the
Yeah.
SRC
I
we
see
have
nothing.
now from our helicopter.
I see
Right in the
nothing.
middle. It's right where the
Continues
cross is.
to
Right
make
where
its
the
final
cross
descent
is.
yeah.
to the terrain below. And once again, just setting the context for this, when we first hit the top of the atmosphere, we were at 27,650 miles per hour. We are now leisurely decelerating under our orange parachute to 11 miles per hour. Incredible amount of deceleration there, as Earth's atmosphere really helped us out quite a bit, getting that initial deceleration, our drogue parachute initially stabilizing our descent, and then ultimately that main parachute bringing us home.
Oh, it's getting very close now,
You
surely.
can see right in the center of that crosshair. That
3
is
minutes on the clock,
parachute with
hasn't
the
it?
SRC dangling beneath.
Yep.
Very historic.
Yeah.
The team on the
Oh, I see the shadow.
Oh,
WB-57 doing a
PDL
great job.
milestone. We have touchdown.
Touchdown.
Hooray.
PDL.
Right.
2 minutes,
Well
56
done.
seconds
3
early.
minutes
Touchdown of
early.
the OSIRIS-REx sample
Fantastic.
return
Yeah.
capsule. A journey of 1 billion miles to
Wow.
Asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system.
And it looks like it's quite
Unofficial
close to that
touchdown time?
road.
8:52 a.m.
That's
Mountain.
handy.
Yeah.
And the team
That's
can
the
now
new
breathe
visitor
a nice
centre, is
sign
it?
Of relief. We now have the sample return capsule, the SRC, containing
There we
pieces
are.
of the asteroid Bennu.
Yeah.
You see the reaction there
There we go.
just moments ago.
Many
as they got that sample
congratulations
back
to them
on the
all.
ground.
Yeah, well done.
NASA,
Well done.
congratulations to, well, all the countries involved, because there was
That's right.
technology on
This is the team at
OSIRIS-REx
Lockheed
from several
celebrating that
countries.
momentous achievement of getting that
well
sample
done, everybody.
from the other side of the solar
We
system
now
at Asteroid
have
Bennu. When we took
on
that
the
sample, we were
ground
over
anyway,
200 million miles away
a
from us here on
sample
Earth.
from
The long journey
Asteroid
back,
Bennu.
1.2 billion
Yeah,
miles
thanks,
from Asteroid
Heidi.
Bennu
Thanks,
back
Ian.
to here with that sample
Hey.
has just come to a dramatic close.
Yeah, so it now
And
the
a little bit
recovery
ahead of schedule,
starts.
too.
Yeah.
The SRC
Yeah.
landing about 3 minutes ahead of
So,
what originally
First
predicted.
impressions, guys?
Well,
absolutely
that was
amazing.
fantastic. Yeah,
Yeah.
I
It was
must
in a
admit
rush
that
to
my
get back
heart
here,
was in my mouth when it
carrying
looked like it was
amazing
ploughing
scientific
in.
information within.
Yeah.
Then of
team
course,
is-
then we thought, well, hang
That
about.
was why it was 3 minutes early.
Yeah.
Well, yeah, the drogue chute didn't open, but it must have done because I think that's what we were looking at.
Yeah.
Yeah, it did look as though it was tanking in, but then they said, because we saw the mountains, and I suddenly thought, well, if it's that low and there's no parachute, but of course we were looking down, so it wasn't the mountains I thought we were looking at. So but yeah, absolutely fantastic.
And what about you, viewers? What did you think of that? Tell us in the comments. Love to know your views as well, of course. And you can guarantee there's a convoy of vehicles that has already set off to the site. As Daz was saying yesterday, I think they're first going to secure the site in terms of possible unexploded ordnance.
That's what the first helicopter's doing.
Yeah.
The second helicopter crew, once they've given all their clear, will come in. They will be wearing hazmat suits, and they will do survey the actual capsule itself, check for any damage, check for any leaking gases or anything like that. Then the other crews will come in, and they will secure it, completely seal it. It will eventually be put into a sealed container, which, as I said, will be filled with nitrogen, and then later on it will be flown to the Johnson Space Center, where it will be sat down. I mean, one of the first things they've got to do now is, once they get it there, is they've got to unpack it from the box, check for any escaped gases inside the box first, but they've got to clean the capsule before they can open it, because again, all the muck and all that it's accumulated coming through the atmosphere has to be removed so it doesn't contaminate the sample. And then they, as they said, they've got to open the container that the sample collector is sat in and clean that out and remove all the samples that have anything that's spilled out. Then they've got to then get the sample collector out and then start removing the samples from there. And all this will be done in clinically sealed units in a total nitrogen atmosphere, so nothing's going to be contaminated.
Ian says it'll be interesting to hear the science when it comes out. What's the timescale for that? Well, they said that they hope to do just an extremely initial release about the data within a couple of weeks.
The 11th of October, they're going to do.
Oh, right, okay.
But this is subject to what happens with the US government. There's a possibility that the government may shut down, and it could affect the time schedule for the opening.
Right.
They're not going to do a live reveal as they open these canisters. They were then going to do a sort of like a semi-live live thing on YouTube, where they're on the 11th of October. That's when we'll start to find out exactly, hopefully, a bit more about how much of sampling they got, and things like that. But of course, NASA, I don't know whether they're staying live for the whole of the collection of this capsule.
No, we don't know. We don't know what they're doing now. We'll just
because they're it's 7 o'clock, because they're going till at least 7 o'clock tonight, because then they're having a news conference. So they may just sit there and just show all of the recovery from now on. You can see the parachute there on the ground, the orange parachute.
That's right.
So
regarding the recovery, I just think it's going to be some unboxing process, isn't it?
Yeah.
Well, first of all, it's got to be boxed. So it's and once they get it back to the Johnson Space Center, and apparently it's the same place where the Genesis samples are still being analysed.
Well, this is the thing, isn't it? I mean, it's not going to take just a few weeks or months to analyse the sample. It will take years by astronomers all around the world, and it's not a quick process, because they want to get right down to the tiniest microscopic level and analyze every single particle that they have to find out what they're made of, essentially, what isotopes they contain, what compounds they might contain. And, it's a long analysis. The thing is, this is cutting edge science because we really don't know. We have good ideas. We have theories about what Bennu might consist of. But as with anything like this, with cutting edge science, you can guarantee there will be a few surprises. I'm sure.
But what you've got to remember also is that all these materials, all this stuff that they've collected, is 4 billion years in the making.
Yes.
So this is going to go back to the very start of to the very beginning of the solar system, and it's and all this stuff. And remember, all these elements, all these things, are going to were made in supernova and things like that. It's going to tell us hopefully so much, because this is pristine virgin rock. It's not been contaminated by the Earth's atmosphere.
And that's not a radio channel, by the way. the other thing is, of course, some of this material may even predate the sun. It may be that old. So it will be extremely interesting over the next few years to see what we find out. And now that NASA have demonstrated that they can do things like this, they're not the first nation to return samples from an asteroid. Of course, that only goes to Japan. But hopefully we can look forward to more missions of this type in the future.
Yeah.
Going back to the mentioning of Sophia, I've just found out in December 2022, NASA announced that both Sophia and the Boeing 747 used to carry the telescope will be preserved and put on display at the Pima Air Museum in Tucson. So I don't know why they were mentioning that.
Unless, it's still operable and they've used it just to track this coming in using because it is an infrared telescope, isn't it?
True, yeah.
So maybe they can still use it. I don't know, but he did definitely mention it. So
so I'll carry on looking anyway, see if there's anything else.
Daz, would you like to carry on telling us about?
Yeah, there's not much more to do with this sample.
So we finished off with the image from Ryugu.
Yeah, Ryugu, which was this little hopper thing that was actually on there. So next up is, of course, the OSIRIS-REx and today, and the sample return that we've just witnessed coming back. I got a funny feeling that could be it. The reason I've got on here the Rosetta mission, which was the mission to 67P Chermanov-Gerasimenko comet, which will in future on this podcast be called 67P. I'm not doing that again. I got it right.
No, I was just going to say, well pronounced, Daz. Well found.
Yeah. But it's because maybe we might have a little chat of what we actually hope. Because as we said, these samples are 4 billion years in the making, and they take us right the way back to, as Andy said, probably even older. These could have come from far, far away. In a galaxy far, far away. So it's going to and the reason I put this up is that this mission, the Rosetta mission, it taught us and with the Hayabusa missions, what the preliminary results. I can't even say. I can say the name of the comet, but I can't say preliminary. The preliminary results from what they found with these sample returns have found some very long chain molecules, which are the building blocks for possible life. So this chemistry is actually going on in space, and this 67P showed us when the Rosetta, because also it had the Philae lander on there, and during its descent it discovered so many different elements, long chain molecules as it came in, and they found some chemicals that are responsible for building RNA, not DNA, RNA, but RNA then goes on is a precursor to DNA. And if you've got DNA, then there's a chance that you've got life. And this is what this is all about, is to find out how all of this, how everything came into being. So yeah, it's really good. I've got some, just to have a quick flow. There's Rosetta on the left with Philae just going down to land. That is the comet 67P on the right. And there are just a couple more images taken from Rosetta. And you can see as it was approaching the sun, you've got outgassing and the formation of the tail. But by analyzing, by flying through this tail and analyzing the surface rocks using spectroscopy, dear me, then they found so much. And this is what we're hoping to find with these samples. So, yeah.
Yeah, absolutely.
Great.
So a good afternoon for science, at least. Presuming that the sample is recovered and there hasn't been any danger in it, it hasn't been lost on the way. It's been a fantastic afternoon for science. We will, of course, as ever, keep you entirely up to date as to what's going on with this sample. If it's at a convenient time, we will bring you the press conference from NASA on the 10th of October, where they will give us a preliminary idea of the sort of things. But of course, we can't expect any detail. It will just be a sort of a helicopter view of the data, and also, of course, be interesting to learn about the condition of the sample, what happened when they open it, and all that sort of thing, which I'm sure be really interesting too.
That was the 11th of October.
Oh, sorry, the 11th of October.
Yeah.
Right.
And can I just point out, we've been watching the NASA stream, and NASA, I don't know if anybody watched the Friday pre-show to this event. NASA, this autumn, there is a lot of asteroid activity, if I could say that. And of course, it started today with the sample return. They're calling it asteroid autumn. So we had OSIRIS-REx sample return, which looks as though it's been a great success. We'll need confirmation later. We've also, it's a celebration, and I didn't realize this. Again, where's time gone? There's also going to be a celebration of 1 year of DART.
Of course, yeah.
That was the redirection test.
God, is it a year?
It's a year ago. So
while you mentioned DART, Daz, I just want to pick up on that, if you don't mind. When they were doing the course corrections for OSIRIS-REx coming back to Earth, just reminded me as well about
Yanis.
The course corrections for the DART missions, and how little the asteroids, but the orbit was changed, but it was still a success. Very little changes in the orbit.
It was changed a lot more than they thought it was going to be. I mean, they were thinking the change might be in the order of 2 minutes, and it turned out to be 23.
Oh, I see.
Yeah.
Right, okay.
But I don't know if you've been watching the news recently. The asteroid has started doing some really weird things.
Yes, I have, actually.
Yeah. Perhaps we can talk about that on Tuesday anyway. Do you want to do that for Tuesday, Michael, and tell us what's going on with is it Dimorphos or Didymos? Which one did they collide with?
Didymos was the one that was diverted, shall we say.
Right. So could you look that up for Tuesday and find out what's going on with it?
Unfortunately, I won't be on Tuesday, sorry.
Oh, no, of course you won't. No, I'll do that then.
The other things that are going on this autumn, of course, we got the launch of Psyche to 16, Psyche.
That's the 5th of October, isn't it?
Yeah, to 16 Psyche, an asteroid of the same name. Now, of course, this is thought to be the core of a protoplanet, and they think it's metal heavy, but we'll only find out when we actually get there. And then in November, Lucy, remember Lucy?
Lucy.
Yeah, she will be flying past a small asteroid called Dinkinesh.
Oh, right, yes.
And this is actually just inside the asteroid belt. And then I think what it's doing is I'm not sure, because it's going to Donald Johanson, who was because Dinkinesh is, if I remember right, it's Ethiopian for what they call the fossil Lucy, which is what the whole
that's right.
I remember that story now.
That's right. Yes,
was the person who discovered her, and it means you are marvelous in Amharic in the language.
American.
So that's why it's called Dinkinesh, and then it's going to Donald Johanson. Then it's coming back to Earth. I think this is the order. I could be wrong. Then it's coming back to Earth to get another slingshot, where it's then going to join the Trojan asteroids around Jupiter. It's going to the Greek camp to begin with,
right?
And where it's going to visit, 3 or 4 asteroids there. Then it's coming all the way back to Earth again, getting another slingshot back out to Jupiter, and it will then visit the Trojan camp, where it will visit another asteroid. And this is a mission that's going to be 12 odd years old.
All the planets will be slowing down by the time we finish.
But yes, it's one of these things. It's just going to keep running backwards and forwards to Earth, getting extra slingshots, and then so it can go to different places, these different asteroids.
Well, I hope they don't find any wooden horses out there.
I know.
Well,
have a look at the. Here we are.
That'd be fun, wouldn't it?
Here's the landing site.
Oh, right.
Oh, yeah, you can see the parachute.
Yeah, there we are.
Oh,
Oh, the parachute has detached then.
Yes.
Oh, I see.
Yeah, well, they usually do detach, don't they? Because if there's any wind, it might drag the capsules. It's the same with when you watch SpaceX and the other capsules come in. The as soon as it hits the water, the parachutes detach.
Right.
So it's not going to be dragged around everywhere.
Well, there we are. There's the return capsule on the ground, looking intact.
Yes.
Yeah.
Looking
it's quite proud, isn't it?
Tickety
Yeah.
All stood up.
Yeah.
That's I mean,
they're all clapping. You imagine their relief.
Yeah.
Imagine theirs.
You can call that. I'm sure you can call that a bullseye, can't you?
Oh yeah, definitely.
Yeah.
But no Jim Bowen.
No.
Yeah. But look how close it was to that road.
Yeah, that's right.
How handy is that?
Yeah.
Yeah.
But as I said, it's going to be boxed up. It's going to be put on a plane and flown to the Johnson Space Center, where it will be when they do their show tonight, which for us will be about 10 o'clock. I'm assuming it'll be on YouTube. I suppose that's when it will turn up there. Yeah, sat quite proud. It looks as though it's all intact. Everything's great.
Yeah,
Nice.
it hasn't. It doesn't look like there's been any horizontal movement along the ground at all.
No,
does it?
it hasn't been dragged or anything. So
that's brilliant.
I can see the parachute now. Yeah,
that's brilliant.
Oh, very good.
Yeah.
Very good. Okay, well, I think we'll draw things to a close for this afternoon.
Yep.
We'd like to thank each and every one of you for joining us this afternoon. We've had more people watching us this afternoon than I expected, so that's lovely. Don't forget to like and subscribe, and especially if you're new here, if you'd like to support Space Odysseys, you can do so by liking and subscribing. We will be back on Tuesday, of course, for our Tuesday live stream at 8 o'clock UK, 3 p.m. EST. On Tuesday, we're delighted to welcome Dr. Sam Morell of the University of Exeter, who's going to be talking to us about gravitational waves and related matters. And that should prove to be very interesting. So tune in on Tuesday, same place, same time, 8 o'clock as normal. So just like to say thank you to Daz and to Roger and for Michael for joining me this afternoon. Thank you to you, our wonderful audience, and say hello to Heidi and Ian and Kev and Astronebulae and our regulars,
usual crew,
usual
and Heidi,
but
usual suspects.
Yeah. But if you are new here, you're very welcome. This is what we do on Space Odysseys. One of the things we do. And we will be bringing you the whole story of the OSIRIS-REx sample over the course of the next months and hopefully years as well. And we've got wonderful missions to look forward to, as Daz was saying, this autumn as well. And where are you going to go for your coverage? Where's the best place? Here, of course. So stay with us.
Space Odysseys.
Absolutely. If it's happening in space, it's happening on Space Odysseys. That's what we always say. T-shirts available and hoodies available. Full details in the description of the video. And the helicopters on the ground, look.
Ooh.
Oh, yes.
So that will be to, as we were saying earlier, just in case there are any explosives that are used on the spacecraft for various.
That's a convenient landing pad, isn't it? The road.
Yeah, it is. Yeah, they will clear the area, or they will scan the area to make sure there's nothing unexploded that might have fallen off the capsule. But there we are. So from the Utah desert and from us all at Space Odysseys, we wish you a very good afternoon. Have a fantastic couple of days before we see you on Tuesday. So
thank you for joining us. Lovely to see you.
Thanks very much. All right, we'll see you soon. Bye-bye, guys. Take care.
Bye.